There is a bucket in your garage right now. Or there should be, because what I am about to show you is going to change the way you think about every rusted tool, every corroded piece of metal, every piece of equipment you have ever thrown away because the rust got too bad and you assumed it was gone forever. You take your rustiest tool, the one that has been sitting in the corner of the garage for 20 years, so covered in rust you can barely tell what it used to be. The hammerhead that is completely orange. The hand plane that has not moved in a decade. The set of chisels your grandfather left you that you have always meant to restore but assumed were too far gone. You drop them in a bucket of water with 1 tablespoon of a cheap mineral compound that costs $3 for a box that will last you years. You connect 2 wires from a car battery charger you already own. You walk away and go to bed. You wake up in the morning, you walk to the garage. You pull those tools out of the bucket. You rinse them under the tap. And you stand there in complete silence because what you are holding in your hands does not look like the tools you put in last night. The rust is gone, every trace of it. The metal underneath is clean, bare, smooth, and gray. The original iron surface that has been hiding under decades of orange rust completely revealed, completely intact, completely undamaged. Not better than before, not improved, restored, returned to the exact state of the metal before the rust ever touched it. This is not a cleaning product. This is not a chemical spray. This is electrochemistry, the same fundamental scientific process that museum conservators around the world use to restore Roman swords, Viking axes, medieval armor, and ancient iron artifacts that are 2,000 years old. The same process that the Smithsonian Institution, the British Museum, and archaeological conservation laboratories on every continent use to recover irreplaceable ancient iron objects from centuries of rust and corrosion is available to you in your garage tonight for under $5 in materials and a battery charger you already own. And the tool restoration industry that charges $50 to $200 per tool for professional rust removal services has never once mentioned it. Welcome to the ancient prepper. If recovering practical forgotten knowledge that the modern world buried under layers of unnecessary expense and professional gatekeeping is what brought you here, subscribe right now and ring that notification bell, because this channel exists for exactly one reason: to give back what was taken from you. To understand why electrolytic rust removal works so completely and so miraculously, why it does what no spray, no chemical dip, no sanding, no grinding, and no commercial rust remover can achieve, you need to understand what rust actually is at the molecular level, and why every conventional approach to removing it falls short of what electrolysis accomplishes. Rust is iron oxide. When iron is exposed to oxygen in the presence of moisture, the iron atoms on the metal surface react with oxygen molecules to form iron oxide, a new chemical compound that is fundamentally different from the original iron. This process is called oxidation, and it is not a surface contamination that sits on top of the metal the way dirt sits on a floor. Iron oxide is chemically bonded to the iron atoms in the metal surface. It forms a physically integrated layer that penetrates into the metal surface as it develops, replacing the original iron structure with a brittle, crumbling, chemically altered material that provides no structural integrity and continues to spread inward into the metal as long as moisture and oxygen are present. Rust does not stop at the surface. Given enough time and moisture, it consumes the entire object from the outside inward until there is nothing left but a pile of orange powder where a solid iron tool used to be. This is why conventional rust removal approaches all share the same fundamental limitation. Sanding and grinding removes rust by physically abrading it away, but it also removes metal. Every pass of sandpaper or grinding wheel that removes rust also removes a layer of the original iron underneath, progressively thinning and weakening the tool with every treatment. Chemical rust removers. The naval jelly, the rust converter sprays, the phosphoric acid dips available at hardware stores work by chemically reacting with the iron oxide and converting it into a different compound that can be washed or wiped away. But chemical conversion leaves a residue on the metal surface, does not penetrate as deeply as electrolysis into pitted and heavily corroded areas, and does not restore the original iron surface with the same completeness. Vinegar soaks dissolve rust through acetic acid reaction but again leave residue, can damage the underlying metal with extended exposure, and do not approach the completeness of electrolytic removal. Electrolysis does something that none of these approaches can do. It reverses the oxidation process at the electrochemical level. It literally runs the rusting reaction backwards, pulling the oxygen atoms out of the iron oxide molecules and returning the iron atoms to their original metallic state. The rust is not abraded away. It is not chemically converted into something else. It is electrochemically reduced back into iron. The original material, or deposited as loose particles that simply rinse off the surface. What is left underneath is the original iron surface of the tool, completely intact, completely undamaged, exactly as it existed before rust ever touched it. No material is removed, no metal is thinned. The tool that comes out of the electrolysis bath is dimensionally identical to the tool before rust ever formed on it, because the electrolysis process has not removed any metal. It has only removed the oxygen that bonded to that metal through the oxidation process. This is why museum conservators use electrolytic rust removal on irreplaceable ancient artifacts. When a Roman sword is recovered from a 2,000-year-old archaeological site, it is typically completely encased in rust, Sometimes the rust layer is thicker than the remaining metal underneath. Museum conservators cannot use abrasive methods because they would remove what little original metal remains. They cannot use aggressive chemical treatments because the acids would damage the ancient iron. Electrolysis is the only method that removes the rust completely without touching the original metal underneath, which is exactly why it is the universal standard in archaeological metal conservation worldwide, and exactly why it works so extraordinarily well on the rusted tools in your garage. The scientific principles behind electrolysis were first systematically documented by Alessandro Volta, who invented the first electric battery in 1800, and by Humphrey Davy, who used electrolysis to isolate several chemical elements for the first time in the early 1800s. Michael Faraday developed the mathematical laws governing electrolytic reactions in the 1830s, the same Faraday's laws of electrolysis that are still taught in every university chemistry course today. By the mid-19th century, the electrochemical principles behind electrolytic metal cleaning and rust removal were well understood in scientific literature. Industrial electroplating, a direct application of the same electrochemical principles, became a major industrial process in the second half of the 19th century. The application of these principles to rust removal from iron tools and metal objects was understood and practiced by scientifically literate craftsmen and engineers throughout the late 19th and early 20th centuries. Museum conservators began formally documenting electrolytic rust removal as a conservation technique in the early 20th century, and it became standard practice in archaeological metal conservation by mid-century. The knowledge existed, the science was documented, the technique was proven, but the average homeowner throwing rusted tools in the trash in 2024 has never heard of it. Not because the information is classified, not because the process is technically complex, but because a tool restoration industry, a rust removal product industry, and a hardware replacement industry collectively generate enormous revenue from the assumption that rusted tools are either a problem requiring expensive professional treatment or simply a loss that needs to be replaced. A homeowner who knows about electrolytic rust removal never pays for professional rust removal services, never buys commercial rust remover products on a recurring basis, and never replaces a tool because of rust damage. That combination of outcomes is commercially catastrophic for every business operating in the tool care and maintenance space. So the knowledge stays in museum conservation laboratories and university chemistry classrooms and never makes it to the garage of the person who needs it most. Here's exactly what you need and exactly how to set this up in your own garage tonight. You need 5 things. A plastic bucket large enough to submerge the tools you want to restore. Any plastic bucket works. Do not use metal. Water. Plain tap water fills the bucket. Washing soda, also called sodium carbonate, sold in the laundry section of any grocery or hardware store under names like Arm & Hammer Super Washing Soda, costing between $3 and $5 for a box that will last you years of rust removal treatments. A car battery charger, the standard trickle charger that most people already have in their garage for maintaining car batteries. And a piece of sacrificial steel, any scrap piece of steel that you do not mind sacrificing. An old steel plate, a piece of rebar, an old steel tool you do not care about. This becomes the anode in the electrolytic circuit, and will gradually corrode away as the rust is transferred from your tool to it during the process. Fill the plastic bucket with enough water to completely submerge the tools you want to treat. Add 1 tablespoon of washing soda per gallon of water and stir until completely dissolved. The washing soda serves as the electrolyte in the solution. It makes the water electrically conductive enough to carry the electrolytic current between the anode and the tool being treated. Without the electrolyte, the water alone would not conduct sufficient current to drive the electrochemical reaction effectively. Do not substitute table salt for washing soda. Salt works as an electrolyte, but the chloride ions in salt solution create an aggressive chemical environment that can pit and damage the metal surface during treatment. Washing soda is the correct electrolyte because it creates a conductive solution without producing any damaging chemical byproducts. Hang your piece of sacrificial steel inside the bucket so that it is submerged in the solution but not touching the bottom or sides. It needs to be suspended in the water with a wire over the bucket rim. This is your anode, the positive electrode in the electrolytic circuit. Connect the positive red clamp of your battery charger to this sacrificial steel piece. Hang your rusted tool or tools in the bucket, similarly suspended in the solution, not touching the sacrificial anode piece and not touching each other if you are treating multiple tools simultaneously. Connect the negative black clamp of your battery charger to your rusted tool or to the wire suspending it in the solution. This makes your rusted tool the cathode, the negative electrode in the electrolytic circuit. Plug in the battery charger and turn it on at its lowest setting, typically 2 amps for a standard trickle charger. Within seconds, you will see bubbles beginning to form on the surface of your rusted tool. These bubbles are hydrogen gas being released as the electrolytic reaction begins at the cathode surface, the surface of your rusted tool. This is the visible evidence that the electrochemical reduction process is actively running, pulling oxygen out of the iron oxide molecules on the tool surface and converting the rust back toward its original metallic state or releasing it as loose particles into the solution. The solution in the bucket will gradually turn dark brown or black as rust is transferred off the tool and into the water. This is the process working exactly as it should. Leave the setup running for a minimum of 8 hours for moderately rusted tools. For heavily rusted tools that have been corroding for years or decades, leave it running for 12 to 24 hours. The longer the treatment, the more complete the rust removal. You cannot overtreat a tool with electrolysis the way you can damage metal with acid or abrasive treatment. Check the process periodically, and if the solution has turned extremely dark with suspended rust particles, you can refresh it with fresh water and washing soda to maintain treatment efficiency. When the treatment period is complete, unplug the battery charger before touching any part of the setup. Always disconnect the power before handling the tools or any part of the circuit. Remove your tool from the solution and rinse it thoroughly under running water. The surface of the tool will be covered in a black or dark gray powder. This is the residual rust that has been loosened and is ready to be removed. Scrub the surface with a stiff brush, steel wool, or an old toothbrush under running water. The black powder comes off easily, revealing the clean, bare metal underneath. Dry the tool immediately and completely using a cloth and then a heat source if possible. A heat gun or even a low oven for a few minutes drives out any remaining moisture from pores in the metal surface. Apply a light coat of oil, any mineral oil, linseed oil, or even standard motor oil, to the clean, dry metal surface immediately after drying. This oil coat seals the fresh, bare metal surface from moisture and oxygen exposure and prevents new rust from beginning to form. The newly restored metal surface is actually more vulnerable to rust formation immediately after electrolysis than it was before treatment, because the original surface oxides that provided some passive protection have been removed. Oil application immediately after treatment is not optional. It is the critical final step that preserves the restoration permanently. The tool you are now holding is the same tool your grandfather bought, the same tool a frontier craftsman made by hand in a 19th century forge, the same tool that a Roman blacksmith would have recognized and used without hesitation. The metal is the same, the structure is the same, the integrity is the same. The only thing that is different is that someone finally told you that the rust was not permanent, that the tool was not gone, and that the process to bring it back has been sitting in chemistry textbooks and museum conservation manuals for over 150 years, waiting for someone to bring it to your garage. The tool restoration industry charges between $50 and $200 per tool to do what you just did overnight in a plastic bucket for under $5. Professional rust removal dipping services charge several $100s for a full set of hand tools. Replacement tool costs for quality vintage hand tools, the kind that were made before modern manufacturing shortcuts, the kind that your grandfather's generation used and that are genuinely superior in quality to most new tools available today, run into hundreds and sometimes thousands of dollars for complete sets. Every one of those dollars was spent by someone who did not know about a plastic bucket, $3 of washing soda, and a battery charger they already owned. Now you know. Subscribe to this channel, share this video with every person you know who has a box of rusted tools they have given up on, and stay with me, because what is coming in the next video goes even deeper into what they buried.